So just welcome everybody who joined us today for today's AI Swiss episode on autonomous machines. It's really hard to pronounce for me as a German, I tell you. But I won't struggle too much with it. And I'm really happy, as you can see here from the picture I share, but also, so to say, live in person, Gurdeep Pall, who joined us today, who's probably might be only a small image at the moment, but if I stop screen sharing, hey, you get in full person. Welcome, Gurdeep, to today's episode.
Thank you, Stefan. Really excited to talk to you about this today.
I'm excited as well. As you remember, we have been talking about having the opportunity to talk for a long time, and finally we made it. So it took more than 3/4 of a year, but hey, I'm happy to have you here.
Awesome.
Yeah, it's awesome. Before I will start to talk a little bit about you, I will give you an idea of some things I had in my mind before that, and I'm not really talking about autonomous machines, but maybe know all those movies I'm sharing at the moment. You might have seen some of them, some not. As you can see, some Her. It's about an operating system, which is more like a person, which is running your life, managing your life, a circle of a machine. So people have discussing a lot about those kind of AI stuff. So what is AI in the future? How can it be dominating the world or not? This is not really what we like to talk about today, to be honest. And it's also not about what Blake Lemoine raised when he was talking about that kind of chatbot from Google, if that chatbot can feel actually or not. So we are more into talking about autonomous machines, and it's slightly different subject. But coming back to my guest today, welcome again, everyone who joined just now. Happy to have you here on board. As always, please remember this webinar software is cool because it has that Q&A section. Maybe it's on the bottom on your screen, on top of your screen. Just check it, the Q&A section where you can actually ask the questions. The difference from today from regarding any of the previous episodes we run is that you can actually ask questions in a completely different way because Gurdeep is not presenting. We are chatting with each other. So this makes it much cooler for me, and it's much easier to talk about the subject of interest. So please feel free. There's no silly questions, as you know. It's just like, hey, come up with whatever you think is important for the subject of today. I'm also happy to have Florian on board as well, who is just in the audience as well. Yeah, here again. Hey, thanks, Florian, for just sharing your picture for a second. You have been also quite a kind of fellow of ASBIS for such a long time, right? For all the time, nearly from the beginning. And so happy to have you here as well.
Yeah, happy to be here. And for everybody on the call, just drop some questions in the Q&A. Yeah, we'll do my best to answer that, to share some interesting links as the discussion goes on. So yeah, really looking forward to the discussion. It's a great topic.
Yeah, I think so too. Now coming back to Gurdeep. Gurdeep, thank you again for joining us. You actually let's talk a little bit about you as a person. You are corporate vice president in technology and research. Bang, that's huge. At Microsoft. So what are you doing on your daily basis?
Well, my remit at Microsoft is to look at emerging technologies and see how we can create new kind of offerings, whether it be products, platforms, that can really transform how we do things in our work and life today. So I've got a very broad remit. In some ways, nobody comes and tells me that you have to work on this or work on that, but there is a very high expectation that the areas that I investigate and I choose to apply company resources to are ones which are truly transformative. So yeah, that's sort of my job.
That's cool. So you're actually kind of a tech scout, right? So checking what kind of technology is quite interesting.
Yes, absolutely. And the way we like to think about it is that Microsoft must operate in three horizons. There is horizon one is what we know and love, large at scale products, Microsoft 365, Azure, Xbox. And then horizon three, and I'll come to two in a second, is really pure research. So this is like, what is sort of now possible that was not possible before, even if in labs or in theoretically. And then, my job is to is sort of sit almost in between those two things. I'm not the one who's creating completely new AI algorithms, but I'm looking at, are these algorithms advanced to a point that a particular problem can be now addressed by them, and we get significant advantage as a result of that. So that's sort of where, where I sit.
Do you have a team to work with you?
Do I have what, sorry?
Do you have a team which works with you?
Yes. Yes, I have a team. Typically, I work with a small group of folks who are really doing a lot of the investigation and early vetting out of different ideas. Once we identify an idea or an area that we believe is significant as a in terms of its potential and it's relevant to Microsoft's mission, then I go pitch to Kevin Scott, the CTO, and Satya, that I think we ought to invest in this area. And at that point, we create a bigger team to focus on that particular area, and then we build it out until a point where we have proven beyond irrefutability that this area is now real. It's got real customers. You can have an interesting business model. The technology works. Then we look to mainstream it into our big motions that we have at Microsoft.
Interesting. So that sounds a little bit like a startup boot camp for me. Yeah.
Yeah.
Like
Yeah.
so spinning off ideas into business units or something like that.
Absolutely. It's a little bit like that. The duration of a typical, successful project that goes through this is about 3 years, I would say.
Yeah.
So it's not like, that we spin out stuff on a weekly basis or monthly basis. Once we decide to invest in it, we will develop it to a point of irrefutability. So real revenue, real customers, real product, real things. And the other difference, I would say from a startup world and what we do is that the areas we choose to go into, it's not totally blue sky. Like, yeah, at some level I explore, but I know what works and what doesn't work at Microsoft. And so, and I know that where we are as a company and where we are going as a company in the long term, like what are the kind of things that we have to sort of look at. So there's the focus is quite strong. And many times when we make a bet, we cannot afford to fail, which is different than some of the startup world where, you put your chips in and then see, which ones work out. So those are the kind of, that's sort of a slightly different lens.
Yeah, that sounds like that. So you're looking much more on the feasibility side. Is it really something which comes into a kind of business model in the end? So you have to be more sure about that. Okay, that's interesting. How long is a typical cycle? How long does it take from idea to getting it to a point where you can say this becomes a product?
Yeah, so I think I would say there's two parts. We can reason about separately. One is that when you're doing absolutely new exploration and building the case whether we should go into this area, that can be pretty random. I mean, there are ideas which Satya and I discussed 3 years ago, which got fun. We got to them 3 years later. Sometimes that happens very quickly. Actually, in case of autonomous systems, it happened within days.
Okay.
That part is pretty, I would say, stochastic. The other part where once you've decided to bet on it, I think 3 years is probably a good time frame in which you can actually build it out, have real customers, see success, learn. I think that's the period. And after 3 years, if you haven't gotten it to a point of irrefutability, you've got to wonder whether is this thing, like, at least as a pure business, intact business, does it make sense, or should we just fold it in as just technology into one of our existing missions, or we just graduate and now it is mainstream, and that's about 3 years.
Interesting. So thanks again for everyone who joined us just now. As you know, I have a fantastic guest with me today, Gurdeep Pall from Microsoft. And we will talk about autonomous machines today. So it was, even if we talk a little bit about his work in the beginning, that's usual, because I really need to understand the context of what you're doing. It's so helpful in understanding what kind of things you're actually researching or doing practically. So the focus is on autonomous machines, as I said. And we saw the movie part, so this is more like the science fiction stuff, and as we hear now, it's more like, hey, can we break it down in real things, right? It's not so much conceptual. I still want to talk a little bit about conceptual ideas behind autonomous machines with you now. So one of my questions I had is actually, can you break down the understanding of what autonomous machines really are? So what does it mean? What does it include? What does it not include? And do we have some examples for that?
Great. Autonomous machines, to me, from a definition perspective, are things that are able to accomplish the tasks that they exist for without intervention of humans all the time. Okay. Now, I want to draw a distinction between automation and autonomous, because automation is something we are pretty comfortable with. And we see it all around the world today. And frankly, you could say that last 30, 40, 50 years of progress in manufacturing and many other fields has come because of automation. So it has definitely been a big step forward, but it is also not a sufficient step as we move towards autonomous. And the difference between automation and autonomous is that in automation, you pretty much control all the parameters. And you say that the machine has to perform in a very, very tight envelope. And it doesn't need to sense very much of what is happening in the outside world or its environment. It is just pretty much performing the same task again and again.
Yeah.
Now, the thing with automation is that it works, certainly gives you scale, but it is very, very expensive to set up and it's very fragile. For example, if you look at just, let's say you're, a car manufacturing company and you're trying to put on a door on a car door handle, and this car moves forward on the track, and then as soon as it comes to a position, this hand comes out and tries to screw in the door. Now, the alignment there is very important. So the amount of effort which goes in to do the calibration and to get the accuracy of that laser, which goes through a hole, and only if that laser is detected on the other side, will you know that you're in the right position. That stuff, getting that right becomes very, very expensive. Now, then the next thing is that if a different kind of a car comes along, well, that requires a totally different type of calibration, and the same assembly line cannot be used easily. So automation has helped us a lot, but it has also come to a limit of how far it can really help us, which says, okay, we need to take the next step. The next step is making it autonomous, and making it autonomous means that the machine can adapt to the environment and to other changes, sometimes within itself, like if you have drift, in parts over time, in itself, to still accomplish the task successfully without requiring human intervention. That is autonomous. And it has to be sufficiently autonomous. Of course, you don't expect, let's say that I have a light switch, which works autonomously, which, nowadays I would say it's still in the automation realm, but it works autonomously. For example, should it be able to change its own bulb? Well, maybe that's a little bit asking too much, but at least can it notify me that the bulb is gone? I think that would be good, because then within, I would say you're sort of, you have a human in the loop for certain interventions, but not for most of the time. And I think that's how I kind of think about autonomous, and anything that is, electrical, mechanical today, I think can be autonomous.
That's interesting that you already talk about some conceptual ideas like environment. So what is environment in machine speech, right? How do you sense environment? How do you limit the sensing of environment? What are important data? How do you deal with those kind of things?
Yeah, and that's where the difference, so if you assume that the human being is fully autonomous, which is not a bad model to have. I mean, you can take it too far, and I'm sure we'll have those conversations. But if you look at human being is fully autonomous, I mean, we have the ability to sense, the ability to plan, and the ability to actuate. We also have one more ability, which is outside of the realm of the autonomous machines that I'm talking about, which I think, where I think a lot of folks start thinking about machines taking over the world. But that piece I'll talk about separately. I don't want to go there. It's just the ability to sense and then decide what action to be taken based on what the sense and given the ultimate objective of the machine, and then actuating the right thing so that you are now able to accomplish that particular task. I think that's really the loop that we're talking about. And sensing can be, in many, many different ways. It can be digital sensors, temperature sensors. When I say digital sensors, you're actually just looking at, curves of things. And it can be mechanical, it can be visual, it can be, so many different kinds of sensors.
I think coming back to some of the words you mentioned, like objectives and so on, to come back to the original, to the situation you described in the beginning. So automation, it's clear, you have a clear task and this has to be done. And of course, we cannot train a machine for 1 million possibilities in that kind of automation thinking, right? So that was the limit we have been talking about, and now we think about having a way of machines doing more like we do. So looking at something, understanding the problem, trying to solve a problem. This is what autonomous means from the basic idea. Coming back to what you said about the limits and objectives. So there's still a kind of minimum configuration of a machine. So autonomous doesn't mean it's just like do whatever you want, because whatever you want, what is it? Yeah. What is I want something? Yeah. So if there's still a kind of force of building or thinking about objectives for a machine, is it something you need to do in the beginning? So thinking about concepts which include some kind of objectives before you start? Do you have to limit the machine in some ways?
Yeah. And this is the biggest difference between, when you sort of dissect a human being as an autonomous machine. Like at some level, we are very, very electromechanical. All the senses we have convert into electrical signal. They go to our brain. We have a policy, and the policy says, take this action, and then we actuate our hands and our eyelids or whatever we do, and we actually get the task done. The piece which is different is identifying what needs to be done. So when we talk about autonomous machines today, that responsibility stays with the human. That is the part that we are not making autonomous. And we'll talk about that. What are the implications of it, and where we are starting to see, where I think we will see some movement before we even come to machines. But we can talk about that, in a bit. So the actual, codifying the objective of why that machine exists and what task it's supposed to perform, it remains with the creator of that machine.
Mm-hmm.
And that becomes the envelope in which the autonomous machine operates. My autonomous electrical light switch is not going to take my dog for a walk. Okay, that is outside of the realm of my.
What a pity.
Yes, but that is outside of the realm of it, because
Yes.
the objective of the autonomous is simply to make my lighting autonomous.
So outside of the realm, yeah, that's also an interesting aspect. Sasha posted a question, and I think it's basically also in the same direction as I'm heading at the moment. Maybe I just ask that here, reading it, okay? Autonomous machines have to take a lot of decisions. Exactly, that's the problem. Like humans while performing planned or unplanned activities. Most cases you can't plan things, right? You need a machine which can react to something in the realm, in some limits, some borders. So currently the decision taking that has been implemented with machines using AI is not very sophisticated. Yeah, we're working on it, right? And it's not transparent how it happens. Yes, another aspect, transparency. What is the machine doing actually? So this is an interesting point, because we as humans do have limits in thinking. So I won't do something because of social reasons, of religious reasons, out of our control reasons. But machine does not have that kind of rule system behind it. So his question is, how will this evolve? And how can we use similar criteria and mechanisms that humans use of trustworthy decision taking?
Yeah, I mean, it's a great question. And I think this is where there's this one underlying thing called context. You know, humans have this incredible ability to accumulate context and to keep modifying it based on situations. So that is like one of the really unique things which we have, and I think that's what, frankly, what AI has been trying to approximate. And we're starting to see some very, very interesting stuff in language, in large language models, which is, which is worth looking at. If I can take a little bit of a detour to answer this question, I'll come back to it. But
Yeah, please.
see, if you look at what is the single biggest thing humans have done in the last 50 years or so, which has completely changed our productivity arc as the human race, right? I mean, intelligence is only 500 million years old, and we've been on this really slow plod, and then suddenly, we're starting to say things take off last 50 years, and then I would say last 5 years are starting to take even a sharper thing. It has been the fact that we have created this amazing Jedi mind trick. The Jedi mind trick is that we've abstracted out a lot of stuff and put it into the digital domain. And we said, oh, by the way, the physical bank where you have to walk in between 9 and 5, and you have to, carry an umbrella, and then you have to reach in your pocket and take out cash and you give it to the banker, that is all in the physical domain. If I had to try to solve that problem by having a mechanical robot walking in the rain to take out a $5 bill to go to the bank, I mean, progress things would be pretty stuck for a long time. What we said, well, actually, guess what? Banking actually can be done purely in the digital domain, and and we can make so much progress, so much innovation there, that. So that's been the big Jedi mind trick, software, this ultimate most malleable medium. We've been able to really to do that. The question then is that we were able to do that because we were able to create software, with logic, with storage, with processes and workflow and user interfaces, and it was all within our control. So whatever the programmers came out of the programmer's brain got codified, and then it executed and performed the task. Now we're saying that, listen, this digital stuff is great, but it now needs to start approximating some of the things that human themselves are actually doing, and that's where it goes into decision making. And you need to tap into some amount of knowledge. Now, that knowledge can either come through scouring the web, which large language models are doing now. I mean, it is mind-boggling, like 4 trillion words they're able to tap into easily. Or it's going to come through some sort of a transfer of expertise from the human to the particular machine. Okay. Now, and I think we are seeing progress on both those fronts right now. So to answer the question, how are we going to get over this thing about context? I think we're making progress on both those fronts. So have we arrived at a place where a machine, an arbitrary machine, my autonomous light switch, does it have the entire context that I'm carrying around inside my head? No. But does it have enough? Increasingly, the answer to that is yes. Okay. Now, again, what scenarios you pick become really, really important. Okay. The level of autonomy that I'm going to be comfortable with and the amount of context that my autonomous light switch requires is actually fairly bounded. And I know that the light switch is not going to, when I put my finger close to it, suddenly cut off my finger. It's not going to do that. It's obsessed on everything, and the context it requires is maybe it needs to know about holidays, maybe it needs about the weather, maybe it needs to know about cheap electricity so it can work more efficiently. But the context is pretty bounded. On the language side, I feel like we have enough context now that it is really the power of the algorithm. And some of the stuff, I can't even talk about with you right now. Like it is really incredible. I mean, if you look at GPT-3, it is incredible. If you haven't played with it, you play with it. I mean, the amount of context able to tap into is mind-boggling. Now, that's language, and we are starting to see a lot happen on the image side. I mean, the generative AI work is incredible, and if anyone is not paying attention to that, I would say please do. We can come back to that topic in a second. But how do you get enough context which can apply to any arbitrary machine? I think that is the gap today, and over time it will fill up. And I think the best way we can fill it up is using the same trick that we use for large language models, which is somehow tap into knowledge, that corpus of knowledge that exists in a readable, in a easily readable form by a machine, because then we can build the AI models for that, and they can take in all that context along with it. Sorry, long-winded answer. I hope.
So one of the purposes of our talk today is really to explore the limits, borders, the edges of what autonomous thinking or thinking about building such machines really means. We're just walking at the edges at the moment with you. Thank you for doing that. If we come back to what you just said about knowledge, so we need some kind of knowledge thinking about language models that use language models. To give you an example of what I like to refer to is I'm just sharing my screen for a second again. It's a small picture. I can actually run it for a second to explain. You know generative design, right? You definitely know it. The fascinating thing about that is if you think about how to build or let a machine build something which is impossible to imagine for an engineer. I like that idea. So this is just within a realm, just building a wall for a plane in this case, and is building it in a very robust way, building it with less costs as possible, with a kind of putting the strings in a way which I would not, I can't not imagine at all, right? So this is one of the examples I had in mind. So this is one of the examples to say, okay, this is one way of a machine having some kind of openness, yeah, to think about a solution which might is not imaginable for a human.
Yeah.
On the other hand, I saw those kind of games from DeepMind. You remember those famous games with the small pixels shooting at each other. And
Atari games.
yeah, exactly, the Atari games. Which come up with solutions you're also not thinking of, but which are not maybe not typical human thinking. So I see the challenges, and I would like to get a little bit more your sense on opinion about that. So on the one hand, we cannot build a system which is completely out of control in some ways, right? So there is kind of control, but there's also a kind of freedom in doing things. Do you have some experience to share from project which is possible to share, where you can see those kind of challenges?
Yeah, absolutely. What we've gotten really good at is basically understanding, finding a path through the complexity. We've gotten very good at that. And you could argue we have exceeded human ability in finding path through complexity. Okay. Now, in order for us, so let me caveat that by saying that for known complex problems, we are able to now bring enough of algorithms, enough data processing, maybe get hold of enough either synthetic data or real data that we can actually go solve it, and probably solve it better than human. There's lots of examples of that. I mean, the autonomous system work we're doing, we worked with a company out of Thailand called Siam Cement Group, and they basically are into polymer manufacturing. And they have human experts who've been looking at designing designing the manufacturing of polymers. Very complex problem, 75 parameter problem, very hard. We were able to actually train AI models to take what the humans were accomplishing in 6 months to getting it done in 6 days. And in that case, the humans actually helped train the machine because it really laid out the lines around that. So I think we, from a complexity perspective, we are in a very, very good place. I think you're going to see a lot of breakthroughs in in chemistry, in organic chemistry, in cells, medicine, drug discovery, because we are now able to see patterns that we never as humans we could do, because AI can actually find that. I think with quantum it's going to get even more pronounced, but that's a different topic. The place where I would say the biggest gaps exist is about new thinking, totally new thinking. Now, you could say, well, all you have to do is introduce this sort of random function in the machine so that it can start exhaustively exploring. Okay. Um, and because we have enough compute, enough this thing, that exhaustive exploration is going to create something interesting. And certainly, quantum, like some of the design of fertilizers and medicines and all, they're actually thinking like that because they feel like, for a certain class of problems, they have just so much advantage that you can actually take that sort of an approach and you end up with discovery. But that place is still purely, I would say, still in the realm of humans. Because today, if you look at just with large language models, the amount of compute, the amount of power that we are actually throwing at it, I mean, the world is right now on a dearth of GPUs. Okay. And that is when we are trying to create maybe a few large language models in the world. I'm not talking about algorithm to actually train them, because that's, if you start training, hundreds of billions of parameters, I mean, you need, that kind of a compute. Like, how are we going to do, exploration of a space 10 to the power 100 to try to do discovery? I mean, I just don't see it as feasible or practical or anything like that. And that's where the human sort of comes in. And that is the ultimate, I mean, position in some ways, right? I mean, our job is not to make humans defunct. Like, we don't need humans. That's not what we want. What we want is that the humans are actually able to focus on things that are uniquely they can do well, and not do things that we uniquely do poorly. If you look at the pyramids, I mean, somebody carried those big stones and built the pyramids. I don't think any human is complaining that some caterpillar machine is taking that job away from me. Nobody's complaining about that. Hey, I'm so happy that they're able to go do that, and all the best to the caterpillars, and give them some extra oil this afternoon. I'm totally fine with that. So I think that's where it comes down to. Discovery is really the realm of the humans. I would say, creativity is a much more complex question, especially given if you see what's happening right now with the generative models. But I would say, yeah, discovery is for sure.
Mm-hmm. Yeah, that's interesting. I got a question from Gaspar, who was actually talking a little bit more about another example, putting this what we discussed up to now to another context, which I like. So let's do that and to see really how we can transfer that knowledge into other domains. He's actually asking about smart cities, and he's asking, are you looking at applications for smart cities? What are the kind of layers in the design and management of cities in which you think autonomous machines will soon play a role? He's thinking of climate change adaptation, for example, at the moment. Do you see other kind of specific application areas for autonomous machines in the context of smart cities?
Yeah, yeah. Well, I mean, what a rich surface area. I mean, if you look at like inefficient analog systems today, I mean, smart cities would be right on top of that. Not in just of consumption of resources, the amount of, carbon and, the waste, and I mean, it is just super. And the reason that is that there is no organizing system. We have very few organizing systems today in cities which sort of work. The sewer system will work, maybe the roads work inefficiently because of all the traffic problems. So depending on the city you're in, your public transportation may work or not work. But it is, I mean, cities are just horrible, horrible examples. I would even go one step further. I would start with buildings. I think buildings are horrible analog systems today, very inefficient, etc. And I
Yeah.
think we can start chipping away at it. We did using our own autonomous systems work. We decided to take Microsoft Campus, and we said, we've got to be able to do better than what the HVAC systems do in terms of efficiency. So we are now operating large parts of our Redmond campus using brains built with our own autonomous systems, and we're getting 20% improvement in just the energy consumption, and that is while maintaining the same comfort level, which is the combination of nitrogen, carbon dioxide, humidity, heat, cooling, all those factors. 20%. We're taking that same over to a data center. So, and this is like an area where you could argue that we've been doing things the same way for 100 years. We've not been able to get that improvement with literally one person spending maybe half of their time for 3 months. We were able to get 20% of the energy consumption of Microsoft Campus. Now we're taking it to other buildings, etc. But that is just one small example. Let's come back to the context point. If these machines, if each of these components of the smart cities were instrumented so that there was, at the basic level, there was ability to sense, at the next level, being able to actuate, we have all the capability today to actually start making these better. I talked about HVAC, but you can look at any other, water, energy, how we're using, how we're storing, how we're dissipating, people movement, carbon dioxide. I mean, all these sort of important factors, even in the open city. So if you have the basic ability to sense and the basic ability to actuate, you can start accumulating context. And it is that context which is really preventing us from actualizing the, what can be done with smart cities. Because I can get all this data, I can now reason with it, and I can build all kinds of, you can do counterfactual analysis on it, you can do predictive work on it, you can put all kinds of policies in place. And that's what will make smart cities better. Is there one thing I would pick on? I mean, I would say if there's one thing you have to pick on, it's probably energy is the where I would focus on. And there is a lot of stuff you can do from an energy perspective that, just basic knowledge of things around can actually help make it a lot better. There are some very interesting projects like in Seattle, there's the project, and there's others around the world. There's a building which is completely, it's a multi-story building. It's an office building, not connected to water, not connected to sewer, not connected to electric grid. And it's a functioning office space, completely self-contained. And by the way, Seattle is pretty gray. The reason I have the light on is because it's pretty gray, and we're still able to sort of manage to get that. The kind of things they do is mind-boggling. Like they, in summer, sometimes it gets warm, like Europe, it's starting to get pretty warm in summer. Sometimes it gets warm. Every shutter and every window is controlled. In fact, they are tracking the sun movement, and the shutters are gradually changing across the entire building. They're opening or shutting depending on their controlling. So if you are able to sense and if you are able to actuate to a very high degree, you can actually accomplish incredible amount of things. And the same idea, just extrapolate that across into buildings. An office building next to a residential building. Of course, this is pre-COVID, some thinking, because people are not traveling as much to go to work, which does change the calculus. But if you did have this thing where you have an office building and a residential building, there is absolutely no reason you should use that knowledge for really optimizing at a higher plane than just optimizing around the building itself. So that's all that context coming in and starting to really transform cities. There is, this is the part which is also very frustrating in the sense that we are able to do so much in the digital domain. We're making so much progress on it. But the moment we hit the analog world, things start to slow down, things start to do that. The place where we are making progress from an autonomous system perspective is where there are larger organizations that can immediately see the benefit of it and can invest in these things. without being subject to, the city council being, and, tax raising and, those kind of things. Because here you can actually, that's why you're seeing, I expect that, a lot of factories, a lot of manufacturing, areas, of course, but even going into like commercial kitchens, I think some of these things will start to get much, much, much smarter, and are getting smarter before we start to see some of the infrastructure start to get smarter.
Yeah. So if I got you right, and maybe for me a short summary at the moment would be, we should start thinking about more narrow in the beginning, so not too complex to big systems. When we start to think about, can we build an autonomous system first? So because I mean, smart cities are highly complex, right? So I just think about those kind of questions. I have a newsletter I get from time to time about AGI. And these are the questions like, this is box for my glasses, right? Why does not a car? Why can't I put a car inside of that? These kind of questions, like making machine understand that there are certain natural rules, which is easy for us to understand because it's clear it's too big and this is too small, right? I can't park a car in there. So think about a smart city, a big city, which is much more complex environment. In that sense.
If I can add one more comment to this.
Yes, sure.
And this is something that we are seeing a lot with our autonomous system work as well. There is this, of course, if you can do greenfield, there is so much potential.
Yeah.
The problem is that most of the world is not greenfield.
Yeah.
And if most of the world is not greenfield, what are you going to do? And I think that's where you focus on the areas which have the biggest ROI and try to make them autonomous. The reason we were able to make a 20% out of, there was not a single capital expense which went in from Microsoft for us to save 20% of energy on our campus. The systems are already there with, these are automated systems, right? So they were already there with all the interfaces. We literally have a cloud service which is running, and a little, well, I guess there's the capital expense, of a little embedded thing, maybe $500, which is basically sitting there, talking to the cloud and then talking to the simple actuation, the state sensing and actuation systems. That's it. And so we were able to go in without saying, hey, Microsoft, let's upgrade our entire HVAC system across the company. We were able to go make it smarter. And I think that is the approach we ought to take for even going after smart cities and smart buildings. And then, you have cities like Neom in Saudi Arabia, the Line. I hope, they are able to take that opportunity to really make it some of the most, enabled for sensing and actuation across the entire city.
Yeah, quite interesting aspect. Yeah, I think you brought up a good point. We have discussed some of the areas where engineering is a lot of part of it, and where we have some natural rules, we have technical rules, also equations which we can use to limit the space of the realm. But you also talked about the natural language processing, and as I can see, Julia Barb also being part of participants today here listening to us, and she is doing a great work in Switzerland regarding NLP and NLP community. Let's talk about text for a second. I remember that we invited Ort, which is a startup in the US, I think more than a year ago, to explain a little bit about their thinking about using GPT-3 to make sense of, or to use it in some ways. And I remember, and I actually tested it myself to think about, can we use it to build some kind of think tanks? So I'm talking about reasoning, understanding. So what I did is, and I was testing it on the playground with GPT-3. So asking questions like, can you tell me how large is the dentist market in Switzerland? Yeah. And I was just watching the answers filling up the empty space of the screen, which was interesting for me to see. And it sounded like, hey, I got a knowledgeable person on the other hand, yeah, just talking to me. But I also saw the limits when I was looking at that, and this was I saw, is it really all the answers I could get? So is it really something also, can I use that system really to be a think tank? So like an expert or some deep knowledge expertise in an area, or where are the limits? Do you know of some examples where I can say reasoning has been completed or shown in a way with that kind of machines, with autonomous machines, in a way which is so exciting that it comes near to more human-like answering thinking.
Yeah. Well, firstly, I will only say this because um, you know, I can't talk about everything right now, but I will say that I think you should assume that the work that has been happening on GPT-3 is going to continue to advance at a pace that will surprise everybody.
Yeah,
So
I think so.
that's one thing I would say. The second thing I would say is that the target, you know, what is the target, right? I mean, should this machine be able to, um, do mathematics like a, particle physics PhD, or is the bar that this machine can do math like an average human being? We should ask that question because,
Yeah.
you know, there are obviously different answers. And so I would say that we can assume that for many practical tasks, this machine will be good enough. And it's just that we have this bar in our head that um, this thing has to be perfect by every measure, and actually no human being is perfect in every measure. It doesn't get good enough. And secondly, what do you intend to use it for? If you um, even let's go back to our pyramids and putting the stones on the pyramid, right? I mean, uh, I'm very happy to do the CAD design of the pyramid, and then hey, go caterpillars, go put the stones. I'm very happy with that. But there is, at the end of the day, if a caterpillar is putting a stone wrong, as a human, I'm able to look at it and say, no, that ought to be corrected. That has to have the right level of intervention that, that can go happen. And I think the same you will probably see here. In terms of the ability, whatever you think, well, it can't do this today, you should assume that it is going to be able to do it in a very, very, probably sooner than you think.
Mhm.
Um, and so those models, just on the back of some very powerful algorithms and access to data and compute power, are just getting very, very, very smart. And yeah, that's how I would put it. And just the bar is tricky. What is the bar? Like, let's say you start answering health related questions. What is the bar that they should pass uh, a doctor's test, or is it a specialist test, or a good specialist test? What is the bar? And I think that's sort of the way I like to think of it. So think in gradations. I mean, human society works on gradations. If I have to work on some modeling some quantum mechanical properties, I don't go to, okay, well, I'm looking for a high school, must have taken calculus. I'm not looking for that person. I'm looking for a PhD. We know that there is gradation, and I'm going to go find the right person.
Mhm. Okay. So since we are a multicultural community with aerospace as well, so having more than the Western thinking inside of it, one of the aspects I would like to discuss, or actually would like to ask you for your opinion about, is also about the influence of culture in building autonomous machines. Because yes, I think much is so obvious for us if I think of Western thinking. But looking at some games like Go, I know there's a completely different kind of thinking in this world, which is also equally exciting, but coming from a different angle. So what role does culture play in building autonomous machines if you think Microsoft is just present in so many countries and so many different challenges and different thinking? How does it actually play a role in building stuff?
Yeah. This is a great question. I would even generalize it more and say, um, what facets do we need to really focus on if you're going to have more and more of this AI be part of our society? Because society is different, geopolitical, social, economic. I mean, on all those dimensions, it is different. And And then how does the AI need to sort of show up there? And I'll tell you the good thing I like. I'll go back from to my early days at Microsoft. So I worked on a lot of the internet technologies, and those days it was the big bang of the internet, and so much was happening so quickly that frankly I don't think, I'm not just saying about Microsoft, I don't think there's an industry we were very responsible. Okay. I remember the browser wars, like, I mean, literally developers were building the next version of Netscape and putting it out on as an update without even sometimes testing it, and similarly other companies were doing it, and I was working on a lot of the internet enabling blocks, and we were just more interested in how do we get this stuff out there in the hands of people without thinking of the ramifications of many things. And moment the internet attacks and phishing attacks and denial of service attacks started happening is when we said, oh shit. And we started to deal with it. And I was the development manager for the TCP/IP stack for Windows, and we were getting attacked. Like, we were doing 10 updates or something a week, because we were just so much attacks were happening. So we were not, I would say, we were not proactively responsible, and we had to pay the piper. Eventually you have to pay the piper, and we did. And we took the entire Windows NT team offline for 1 year to harden the security of it. You probably remember 2003, 2004. And so in this case with AI, I think we are trying to be responsible. And when I say we, I mean a lot of the core companies that are sort of focused on it are actually, we have a whole group. We have some really smart people looking at responsible AI. And it's saying, like, what are the, even dimensionalizing, what does responsible AI mean? Okay, once you've made yourself, educated yourself, and this is an ongoing process, you then get into what are the systems you're going to put in place? What are the standards you need to in place? How do we educate people? How do we educate customers, and so on? And I think that is something that I really like, that is happening in the industry, and I want to see more and more of that, because that is how we are going to really address, some of these cultural gaps between cultural expectations, what we need to do, what we need to adapt. I'll give you one example, right? Like this, the sort of giving human form to AI. Is a very tricky thing. I mean, it's just not just about the uncanny valley of, the behaviors of this thing, which over time is just going to get better. But it's like, what is even the ethical implications of that, right? Like, let's say that you are looking at, and it's not me, you're actually looking at my avatar, and we're getting to the point where the photorealistic avatar that we've seen, some of the work that is coming out on Facebook and some of the others is incredible. I mean, they're able to do transformations on human faces in real time, and like passing the the Moss score of the testing uncanny valley. What is the ethical thing? If you hear something from me, have you heard it from me? How do you know that I gave permission, that these are my words that my avatar is allowed to actually use on my behalf? I mean, we are focused on the more sensational stuff, right? These fake videos going around.
Mm.
But like, you just look at on a day-to-day basis. Of course, it's happening in the realm of geopolitics, but you look at on a day-to-day implications of that.
Mm.
And there turns out that there are groups of populations who'll be fine with that. There are groups of who will not be fine with that. How do you go after that? You look at even like, just to look at from an analogy perspective. There were a lot of people in the late 90s and 2000s who said, well, any content should be free content, right? Like, and there's a huge campaign and blah blah blah, and then there were all these rules and things kicked in, and eventually the commercial interests sort of got a control over or control of it, and we came to sort of this happy medium. What is that happy medium here on each one of the dimensions that we are talking about? So I would say responsible AI is a very, very important piece of this. It is particularly important for autonomous systems. Like, I'll give you one example, which I think is for autonomous machines is particularly interesting, right? Because a lot of the other things we say, on the realm of the esoteric, and yeah, it could be this, but if you wrote it in text and if your avatar said it in words, then it is okay, that kind of thing. But let's say with a machine and a human are working in the same space. This, I think, is one of the hardest scenarios, and I think that and that's why autonomous driving is hard. But I would say, even like, you look at machines and all. Like there has to be a contract between the machine and the human. And it doesn't mean that the machine, that there'll never be an accident. You can never protect that. But the contract has to be there up front. Because without that contract, nobody will want to enter the same factory floor. And the contract, I would argue, going back to transparency of models and all that, is that sure, you can have a model which is totally opaque. I mean, weights and 1 billion parameters and weights, nobody can make sense of them. Of course, now we're training models to make sense of that complexity. But what if we said that, listen, wrapping this entire black box of billion weights is actually a set of very simple rules. And these rules are the contract, which is between the human and the machine, which is that there is a dotted line. This machine, regardless of what the 1 billion parameters tell it, it is never going to operate outside of this dotted line circle. And it's marked, by the way, on the floor in red. The human knows, the human doesn't understand the 1 billion parameters, okay, but it knows that I cannot go into this red dotted line thing. And if I do, if anybody violates that contract, then you get an accident. But you have to, so that is like an example of responsibility up front. This isn't like take a model and throw it onto this machine and then we'll see what happens. No, you've got, all this has to be pre-computed and thought about. And that I think is, I feel like the AI practitioners and the roboticists and the mechanical engineers, etc., really have to come together here. And neither one of them will be able to solve this problem alone. The level of safety, there's the level of conservativeness which is inherent in people who build machines, because they have seen the consequences of lack of it. But that thinking has to be combined with AI thinking. The AI folks don't know all that. They want to throw stuff on the wall. It's like the same Netscape browser in 1995. But you've got to put these two together. And then I think we will get workable autonomous machines, which will then move the world forward.
I have two questions left. So one thing is a very practical question. So with all the applications we have been talking about up to now, what kind of industries do you see are best fit for autonomous machines at the moment currently? So is there kind of a difference between the industries? So is it more applicable in that kind of context than in another?
Well, I would say my answer is yes. We are seeing it's not so much even by industry. I think it is use cases. And I think the more bounded a use case it is, and the more value of making something autonomous is where we are seeing a lot of traction. It's been surprising to us in autonomous systems work. We have seen everything from scenarios which are in pharmacy manufacturing, to polymer manufacturing, to HVAC control, to mixing paints, to inspecting components, to designing shoes. I mean, it has been mind-boggling to us. And obviously we are not experts in all these industries. We don't even know what we don't know. So we have tried to talk about the capabilities in a way that we can get the more curious folks in these industries say, oh, let me try it out. And every time they try it out, it is like transformative. Then they have the problem of trying to convince their management. We should totally, go on board with it. The reason Pepsi and the PepsiCo has been one of the more vocal, positive, advocates of this, because when they saw the success in one or two use cases, they said, I want to put it all over my company. I mean, the CEO is like getting up and tweeting about our stuff. I mean, when PepsiCo CEO, I mean, is talking about. So I think it is really the use case, being able to, which has very high value, and it is fairly well wrapped up that we can actually make rapid progress on across the entire surface area. So I don't want to limit it and say, that industry versus this industry. I think it's very broadly applicable. It's like software, like if you ask me, like in 1995, which industry do you think software could really help benefit? Yes.
Okay, when you started your talk today, sharing your experience, we were talking about the text scouting thing, and my question would be, what kind of sources do you use? Is it research papers, or are you going to conferences? Where do you actually try to stay up to the next level of what's happening?
Yeah, so one of my really life's good fortune is that I get to work with some incredibly smart people. Um, so I get access to information and signals and thinking that really helps me where I should go dig more, what I should learn more. So this is probably not a unique answer. Like if you go talk to, folks who work in, these really, think tanks or work in universities or labs, they really feed off of each other's, knowledge and exploration and judgment. Like today, I'm sure you've heard the statistic, like the number of papers that are coming out on NeurIPS or going into NeurIPS and then is so high that it is impossible to, like, a single person to consume all that. So what do
Yeah.
you do? If you can't consume everything that's going in NeurIPS and you want to stay on top of stuff, what if you miss something important? Right? And that's where you have a network of folks and they're all exploring and then percolates up and say, that it looks very interesting.
Hmm.
And then like in 2016 when the first, I think it was 16 or 17, when the first paper on transformers came out, the paper from um, um, came out of Google Brain, it's called Attention is All You Need. And that paper, of course, I later found out that the first author on that went to the same undergrad college as me in India. I didn't even know that,
Okay.
but that's besides the point. But when that came out, I was at that time we were working on a very large early versions of today's large language model things, and the person who heads up our language research in Microsoft now, he was in my team, and he first educated me about that. And they were already starting to incorporate some of the attention ideas into this thing because they were all struggling with the same issue. With LSTMs was the big thing before that, and the biggest thing they were using is really the attention framework. And so it's really about, I get a lot of the signal, and I also do some random exploration myself, but to contribute back to this, whether if I find something interesting, I'll share. Of course, I share on LinkedIn, of course, but I also share with my colleagues and say, hey, have you looked into this? And this piece of it looks interesting, and try to stay informed and on top of that.
Fantastic. So I just want to remind everyone who's just with us today and listening to what Gurdeep has to share here. Here's a wonderful timeline on LinkedIn. Just follow his timeline. He's actually posting a lot of interesting stuff worth to explore and to have a look at. And I saw Florian also posted a link to the Microsoft Research Group and with a lot of cases on autonomous systems. I saw it in your timeline on LinkedIn as well. So thanks for that, Florian, just to share that with us. That's awesome. Some of that, and I was just fascinated by it because some of the cases you can actually read there have been invited to us. So we talked about that in the past already, which is it's just fun to watch and to see how we're just moving deeper and deeper into what those kind of things. So looking a bit at the time and the time we spent already with us, I'm so happy that you took the time, the valuable time you have to share with us your thoughts and ideas. And I appreciated a lot your experience, which you shared with us.
It's been great chatting, Stefan. I know we've been trying to do this for a while, so I hope it was useful. It's at the end of the day, it is we have to be we move forward collectively as a society, and everybody participates. And I hope these ideas, and get other people thinking and get people more lean in and contribute to taking all this stuff forward.
Are you working closely with OpenAI?
Closely, yeah.
Yeah, cool. So again, thanks again for being with us. Morning time on your side, evening time here. the times differ from everyone here who joined. Thanks again for everyone who has been joining us today. Thanks for being part of a journey for a long time. I see some of the names just repeatedly coming back, which is awesome. And I hope to see you once again back to one of the next episodes, which are still in the planning. And I will let you know when we are up and running. Have a nice day, and thanks again for the time we shared.
Bye-bye. Thank you. Thanks for having me. Bye-bye.
Bye-bye.
Take care.
Take care as well.